Hello and welcome to another session here at Techorama. I'm super thrilled to be here in front of such a huge crowd. It seems that a lot of people share one of my passions, and that's C#. You all came for 1 hour of C# source code, of pattern matching inside out. Some people who are not so much into C# could think that pattern matching an hour could be a waste of lifetime. I don't think so. I think it's super interesting and I'm looking forward to spend this hour together with you. My name is Stropek. I'm a passionate programmer. I have been a passionate programmer for nearly 30 years. And I know C# from the very, very early days. I started with working with C# when the first technical previews came out, and it has been one of my favorite languages ever since. So I decided, this Techorama, we should look into a feature which I would say belongs to my, let's call it, everyday C#. You know, there are C# features that I rarely use. They are super cool to talk about, but you rarely use them. And then there's this everyday stuff that you use in every method, in every class, and a lot of aspects of pattern matching belongs into exactly that category. So I think it's definitely worthwhile diving deep into exactly that topic. Now, today's Techorama is all about jungle. We are here at the jungle edition of Techorama, right? So I thought, why not taking this topic of pattern matching and embed it in a nice little story? So I engaged a co-author for my talk today, and this co-author is ChatGPT. I had a lot of fun because I went to ChatGPT and said, hey ChatGPT, I would like to talk about C# pattern matching, but I would like to do it in a kind of storytelling way. And the story that you will hear in the next 60 minutes was developed in a kind of dialogue between ChatGPT and me. So let's start by introducing you. You are a wildlife photographer. You see here this robot, that's us. And as this wildlife photographer, we are on an expedition through the jungle. You are following in the footsteps of your biggest idol, the famous wildlife photographer Jim Corbett. Now, unfortunately, Jim passed away after a long and adventurous life. And Jim has left you his notes and his camera. However, Jim was not a very organized person. His notes are all over the place, and you cannot really read it. And your first job, our first job, is to use pattern matching to make some kind of sense of it, to understand what Jim was writing down. And we're going to do that in the first part of this talk by looking into simple type patterns. So let's go here. And in this talk, I'm going to copy quite a lot of code. It would take too long to write everything by hand, and you wouldn't get a lot of additional knowledge from it. So I'm going to copy code from prepared material. Obviously, all the code that you see, including my slides, are available online. I will post a link on my Twitter account after this session, so just take a look at my Twitter account, it's rstropek, and there you will find it. Let's get started by creating a region for our first little part here. And in this little part, we would like to write a small method, a static void makes sense of. And now we get the notes of Jim, of our idol, and in this case, we get an object. Oh, we have no idea what Jim means. That's just a note, and we have no idea what Jim means. So let's write a little header here, nothing special. As you can see, it's just an object, and now we are going to use pattern matching to find out what Jim really meant. I think in this case we can disable GitHub Copilot, right? Because I'm just copying in code, otherwise it would spoil a lot of things. Let's do the first very simple thing just to get warm, but don't worry, if you are a C# pro, it's going to be more elaborate later on. So this is the first little pattern matching thing. Let me introduce you to type patterns. You can just say O is string, and that will be true if O is a string, and false if it's not a string. And if it's a string, we say, oh, this looks like a word, not a number. We still can't decipher anything. So we can do a little bit more, and immediately it's getting more interesting. Let's check this one. I will zoom in so you can really read it very good. So this is the traditional pattern matching that you have seen before, but now we have an additional variable here. Now what's this variable? This is a variable declaration. What we essentially do is we are declaring the variable animal name and we are assigning it a value O as type string. And this value is only assigned within the code block of the if statement. But there is a very important gotcha here. The variable animal name has the scope of the if statement, not the block. So animal name, the variable animal name is now taken. You cannot reuse it anymore. That's an important one. So the scope of animal name is now the entire method because we have it here. So in detail, you can read this like that. You can say this is the pattern matching and this is the declaration of a variable, string animal name. So we are combining a variable declaration and a pattern matching. And now you understand why animal name is now taken in the scope of this method. We call this feature also a definite assignment feature because the variable animal name only is definitely assigned within this code block, not outside. But the variable name is taken. We cannot use it anymore. Now what else can we do? We can, for instance, check against constants. This is a constant pattern, you see? Oh, what? A tiger? There are tigers here? We have to be really, really careful. So this is a constant pattern. We are going to use constant pattern a lot here. But don't get me wrong, this is not just checking the constant. Of course, it's also checking the type. This is checking the type of the string tiger, which is obviously string. So we essentially say O is string. And additionally, we are checking for the constant tiger. So don't worry if you think that this is taking a lot of runtime. It's not. It's just very simply translated into plain C# that you could have written yourself too. Well, what is the difference between is tiger and something like this? Okay? The important thing is this will not work for many data types, as you know. I just mentioned boxing. Anybody? Maybe you can remember that. So you can use the equals operator, but then you can override the equals operator. This does not use any overridden equal operator or equal operator overrides and so on. They are not used here. Is really just going on the object here. Now, what if our friend Tim, our big idol, has written down a number? Let's do another very simple type check here. And as you can see here, the numeric value can be checked exactly like the string. Absolutely no problem. But then we can use this variable numeric value inside of this block. If the value is greater 100, we probably found a flock of birds. It's probably a photo of a flock of birds because no other animal appear in such large groups. And if it's lower than 100, it's probably a smaller number, maybe the number of eyes of the thing that Jim took a photo of. Well, obviously not. We really don't care. We are mainly interested in exactly that pattern matching here. So here you see this thing is now an integer and can be used inside of this code block. Of course, you can use more advanced types too. So for instance, you could use a tuple or tuple. Let's not get into that, okay? So I will say tuple. Here I have a value tuple, which is a structure, a value type in C# consisting of two integers. And here it seems that our idol Jim has written down the focal length and the shutter speed of the photo that he took. Luckily, he wrote it down. So this is how you can check for more complicated types. In this case for a tuple, but please use your imagination. Obviously, you can use other types here too. So pretty neat here. And again, same topic. This is the pattern. This is the declaration of the variable. And last but not least, here in this small little first intro demo, we can obviously here also combine all these things. So if we don't have a string, and if we don't have an int, and if we don't have a value tuple, yeah, then it's a mystery. We don't know what we have here. So you see, this is combined pattern matching. Obviously, you can use and or. That was kind of clear. So if we try this one, and I have written down some method calls here, we can obviously give it a try, say .NET run, and let's see if our little program works. And everything should be okay. It is not okay. Why is it not okay? What did I miss? Well, I didn't call the method. Oh, that's clear. I kind of messed up the curly braces, but now we should be okay. Let me run it again for you. Okay, looks very good. So you can check it. You can check my code later on. It recognized the string. It recognized the number. It recognized the tiger. So please take a look at the code. You can pass in whatever you want. It recognizes the tuple, and it also recognizes if it doesn't recognize anything. So that was just to get warm, okay? That was just to warm up a little bit, and now we would like to apply this knowledge to a little bit more complicated scenarios. Now, just a few days in the jungle, you already made a ton of pictures. And here are two of those pictures. You are very excited to see what you have captured. You are looking at the very first picture and see a strange animal. I mean, strange animals? Somewhat, yeah? It's time to take a more structured approach. Let's build a system to kind of structure and classify the animals from which you took some pictures of. Okay, so this is our next job, and for that we are going to create some custom types and do more advanced, more elaborate pattern matching. So I asked another friend of mine to come up with these pictures, by the way. So thank you to Midjourney. It was a pleasure working with you as my designer for this talk. And now I went back to my friend ChatGPT and asked ChatGPT, hey, I have the idea to present a lot of animals to an interested IT crowd. So could you please help me coming up with a bunch of very interesting and funny animals that we can use in my talk? So let's paste in some code and region, and let's take a look at this code. We are going to need it in order to understand what we are doing here. Let me point your attention first to our first type. We call it iAnimal, and we have the number of legs, the sound that an animal makes, and the colors that this animal is. Then, next thing, we are implementing a record. I call it animal here. And yes, many people don't know that. Records can implement interfaces, absolutely no problem. And records can also be abstract, so you can build hierarchies of records. So in this case, we have a mammal record, which is a derived record from animal. And we also have birds, of course. Now let me introduce you to our animals. The first one, obviously, is the Fluffosaurus. We will need that one. It's him. This is the Fluffosaurus. I think I don't need to read everything. It's a large, ultra fluffy animal, and it's typically in bright pastel colors. It has typically 6 legs, and it makes a very interesting sound, something like purr, purr, I don't know, something like this. Now then we have the screeching sunflower. Unfortunately, I don't have an image from this creature here. It's a kind of bird shaped like a sunflower. Then we have the giggly glider, which is a small bioluminescent creature with 4 legs. I don't have a picture from him either. And finally, we have the centipede cuddlebug. Luckily, we already took a picture of him, so it's perfectly fine. Please remember him. He has a lot of legs, and we will need that when we do pattern matching, okay? So now you understand the data model. I simply didn't want to do another bookshop example. I wanted to do something which we are all familiar with, and everybody knows the centipede cuddlebug, don't we? Oh, of course. Kind of. Okay, so let's do the next example, and let's go into more elaborate pattern matching. Let's start another region here. I think I can fold up the first region. Here we are. And region. And let's add another method here. This one. Let's write a header, and then let's get going. Let's switch over the object. Again, it's an object because we don't know what the photo is all about. And now we want to do various type checkings. First one is a simple one. We are going to use a type pattern inside of a switch statement. That's important. It's a switch statement. So in this case, we are saying if object is a Fluffosaurus, then we simply write, hey, we have a Fluffosaurus. That one was an easy one. Now we would like to handle in a more specific way a Fluffosaurus which has 8 legs. Oh my God, have you ever seen a Fluffosaurus with 8 legs? I'm not even sure if something like that exists, but it looks like it really exists. And the important thing, technically, is that we now can combine the pattern, which is here, the type pattern, together with the definite assignment, this is this one. So we are essentially declaring a new variable called Fluffosaurus, and then we can use this variable immediately here in the when clause of the switch statement to do a more detailed inspection of the Fluffosaurus. It has to have 8 legs, otherwise we are not interested, and we are very lucky that we find a Fluffosaurus with 8 legs. Now it's super important to keep in mind in C# that the order of the patterns is super important, because if we mess up and do something like this, C# will shout at us and will tell us, hey Ryder, that's not possible. Every Fluffosaurus is a Fluffosaurus, even if the Fluffosaurus has 8 legs. So the switch statement would immediately enter here this case, and it would never enter this case here because the when clause is a special clause here. So the order is really important. In many cases, like here, C# is super smart and it recognizes that you messed up, that you did something wrong. However, there are other cases which are even more complex that you will see in a few minutes, where C# cannot recognize whether you used the correct order or not. So this is the when clause combined with pattern matching. Now let's use here another thing. And let's say we want to check mammal. And again, we get an error. Why do we get an error now? I mean, Fluffosaurus and mammals? Now we can remember. The Fluffosaurus is a mammal. So this is the base class of Fluffosaurus. So that is the case. So in this case, C# recognizes that again, mammal is the more generic case. Therefore, it has to appear after the special case. So it's not just validating whether you use the when clause correctly. It also understands the hierarchy of your classes, how they relate to each other. And then when they do, it's checking whether the special case appears first. So in our case, we have to handle the mammal case after the Fluffosaurus, otherwise it wouldn't make sense. It's kind of clear that we don't need to just use records here. We can also use interfaces. So we can switch case, we can do a type checking, not just based on our own classes, structs, record classes and record structs. We can also check for an interface. And again, it's important that iAnimal appears after mammal because mammal is an interface implemented by the base class of mammal. So therefore, the more generic case is iAnimal, even with the when clause. And this is also interesting because, again, we have our type pattern, then we have the definite assignment, and we use the definite assignment in the when clause, although we have an interface. That's perfectly fine. So you can use when clauses with interfaces without any problem. And then, woohoo, an animal with this number of legs, more than 10 legs, that's really unusual. And of course, iAnimal is the generic case. Last but not least, sometimes our friend or our idol Jim wrote down not just a specific animal, but just a text. And we interpret this text as a string, as you can see here. So we can mix and match our custom data types like interfaces, records, classes, and so on with standard data types like that. And in this one, it's kind of interesting that you can also use here in the when clause methods, and you can dot into properties and use other relations if you want. So the when clause can be as complex as you want. It's really up to you. It has to be just an expression here. And finally, I already told you that we can do pattern matching with constant patterns, and null at the end of the day is also just a constant. So if we took a picture and there is no animal in the picture, we maybe get null, and here we handle pictures which don't have an animal on them. So therefore we can add null handling, as you can see. So you see, the switch statement together with pattern matching and the when clause is a pretty powerful thing. Let's try it, right? Let's try it. Let's add something here, and this time I'll do it correctly. Here we are. Oops. I messed up. So here we have my calls. Let's put the calls here and let's take a look at them. We call recognize with a Fluffosaurus. Then we create a Fluffosaurus with 8 legs, then a giggly glider and a screeching sunflower, and then the centipede cuddlebug with 500 legs. Oh my god. And then we simply add a string. By the way, do you all know this new way of writing down strings in the latest version of C#? I really like it. I really like it. If you don't know this feature, let me tell you what it does. It essentially removes the carriage return in the line feed in the first line. So it's the string does not contain the first line feed, and it also removes the blank area here on the front. So this is really nice. The string is essentially cutted exactly here, where you have the 3 quotes here, double quotes at the end. And by the way, if you really want to get crazy, you can add as many double quotes as you like, and I think we definitely should do that. I mean, the centipede cuddlebug has 500 legs, so we have to have a lot of quotes, right? It has to fit to each other, so that is perfectly fine. Of course, you shouldn't do that in practice, but you can. See, you can. So that is just a string, a nicely formatted string. This is something new in .NET 7, by the way. And then we can call recognize with null. Let me quickly check whether this works. I will not walk you through the results. The results really work. I checked them before I went here on stage. So you see, it recognized a mammal, it recognized the centipede cuddlebug with 500 legs, and it also recognized the null value just as we expected it. So that is pretty fine. Our second part is now done. Let's quickly repeat and summarize, and then we'll move to the next one. The difference from the first example to the second example is that I use my own types. That's the first one. And the second one is I now use the switch statement, not the if statement. But don't get me wrong, all these things here, something like this, and also something like this, and also something like this, it can be used in an if statement too. It's nothing special. However, the when clause is special. Good. Nice. So, let's fold this one up and move into the next area. Here we are. You see, being on a wildlife safari or a travel expedition is really expensive, and you see our wallet is already empty. So what we need to do is we need to make some money. So we decide to sell some of the pictures to a magazine. The magazine is interested in pictures of animals that live in a kind of symbiosis, so 2 animals living together, and they are particularly interested in the Fluffosaurus and the centipede cuddlebug. And for some strange reason, they are really into legs. The more legs these things have, the more money we get. It's kind of weird, granted, but hey, I'm not complaining, I'm just taking the money. So what we are now going to do is we are going to take a look at recursive patterns by reusing the type system that we created. So are you ready for some recursive patterns? I definitely am. So let's set everything up for the third region here in our demo. Recursive patterns. In this case, I get a list of animal combinations. Let's call it a symbiosis. So we need a new type here. This type looks like that. I will introduce it to you. Here, you see, it's again a record class. If you leave out the class here, it always becomes a class. So you can also write struct if you want, for those of you who are new to this kind of record stuff, but we are going to use record classes. I call it symbiosis, and a symbiosis consists of animal 1, animal 2, and then a flag whether the symbiosis is mutual. You see, either the two animals can live together and they benefit both from the symbiosis, then it's mutual. It can also be that they are neutral, and it can also be that one benefits from the living together and the other don't. Then it would be false. So this is symbiosis. And now what we have is we have categorized all our images based on this symbiosis data type here. And now we need to come up with valuable pictures, or with the total amount of money we are going to make by selling all our pictures of symbiosis. Let me show you how we do that. I came up with this method signature, find valuable or find total revenue. Let's call it this way, and we get a collection of symbiosis records, and we need to return the amount of money for each picture that we make and a little description to just remember why we are earning this money. This is what we are returning, so this is a tuple. We are returning a tuple here. So let's write it here in an expression-bodied member form. Let's do a symbiosis. This is our thing here, and we go here and then do a switch. But this time we are not going to use a switch. We are not going to use a switch statement, but we are going to use a switch expression. So please note that this is not a switch statement, it's a switch expression. Okay, let's get started. Now we have something which is pretty interesting. Symbiosis is a data type. And the first thing that we want to check is whether the photo contains a Fluffosaurus with 8 legs and a centipede cuddlebug with a lot of legs. How many legs is important because it figures, with that we can figure out how much money we are going to earn. Let me show you how we do that, and then I'll walk you through the code. So this is the code. Let me show you what we have. So this is really a checkbot. We have the Fluffosaurus and the centipede cuddlebug together. We have a Fluffosaurus with 8 legs, and here the number of legs are defining how much money we get. That is really awesome. We hit the jackpot. But now let's take a closer look technically on what we do here. I will zoom in so you will see it pretty clearly. Here we are indicating that we are using a recursive pattern. It starts with a curly brace. We are telling C#, hey, this is a pattern, but not a type pattern on the variable, but we are looking into the variable. Now we are looking into the first animal here, and we check with a type pattern. This is why it's called a recursive pattern, because we look into it and then we can go from there and look further into it and so on. This is why we call it recursive. So here we are going into the animal 1 and checking, doing a type check on the Fluffosaurus, and now comes the next recursive pattern, again indicated by the curly brace here, and here we are checking a property. We could call it a property pattern, and inside the property we check here for a constant. But you can use anything here, don't get me wrong. This is just a pattern. You can use another type pattern here. You can use, if you already know it, we'll talk about this in a few minutes, you can use relational patterns here. You could use a list pattern here. You can use whatever pattern you want. This is really just a pattern, and it can be another level of recursion too. Now in this case, we are just saying the first animal must be a Fluffosaurus and the property number of legs has to be 8. The second line, I have to zoom out because the line is too length, but I think you can read it, hopefully. The second line checks whether the animal 2 is a centipede cuddlebug, and in this case we are also doing a property recursive pattern, but here we have something new. See? var legs. The var pattern extracts something out of the matched pattern, and again we have a definite assignment. Definite assignment means here that we can use the var pattern to declare the variable inside of the pattern matching and then use this variable immediately inside the corresponding code block. In my case, I'm using the number of legs to calculate the amount of money we will make from this photo, because the magazine is into legs. If they are into legs, they should get legs. I hope you understand what I want to tell you here. So this is recursive pattern with constant pattern and the var pattern. Now we can take the next thing, and the next thing is not the jackpot, but still pretty good. Here we are. It's just a Flaphosaurus and centipede cuddlebug. So here we are using only one level of recursion. Now let's check what's going to happen if I move that one up. Yes, exactly what we expected. C# will tell us that the generic case is now before the special case, and that doesn't make sense. So let's move it down again, because the generic case has to be after the special case, and now it's okay. We have at least a Flaphosaurus and a centipede cuddlebug. We get 75 euro or dollar or whatever, and that's not too bad. Still 2 correct animals. Now, with some photos, we aren't that lucky. So what we have there is we have a Flaphosaurus, granted, but the second animal is unknown. The underscore here is the discard operator. Strictly speaking, we don't need this line. We could simply leave it out. Then we would not express any kind of filtering. But the underscore, the discard operator, allows us to be explicit about it, to say, I don't care what the second animal is. So a reader of our code understands now that I don't forgot the second parameter. I really didn't want to specify it. And last but not least, it's important that the symbiosis is mutual. Then we get 50 euro because we don't have a centipede cuddlebug, but at least a Flaphosaurus. Now, next one. Let's copy the last 3 of them because we can handle them all here. Now I will maybe go here and put that in the next line so you see it a little bit better because the font is so large here. And I will zoom in so you can read it properly even from behind. I would like to draw your attention first on this pattern here. Now this pattern is a very special thing here. We are using obviously a recursive pattern here. We talked about that already. But now we are dotting into the first animal, and that is new. I can't remember if it was .NET 6 or .NET 7 when this came out. I think it was .NET 7, but I'm not 100% sure, so you have to check. If you are on .NET 5, I'm pretty sure that it doesn't work, but afterwards you have to check. If it's .NET 6 or .NET 7, just simply try it. So we do not need, strictly speaking, to do something like this, see? We don't need to specify a recursive pattern here. We can also dot into the object directly when specifying the pattern. That's pretty new. And then here, look at this thing of beauty. We can specify a relational pattern right inside of the recursive pattern. We'll talk about recursive pattern in a second. I have a separate chapter on that because it's super important. So here we can say the animal 1, I don't care which type it is. It's already known that it is an I animal, so we can dot into the interface and then apply a relational pattern on it. Relational patterns would be one of my favorite things in C# if there wouldn't be one very specific limitation. And it's driving me crazy, but it is like it is. This must be a constant. You cannot apply a variable here. You cannot say greater than something read from the database or a setting read from a config file. This simply doesn't work. You have to specify a constant. And unfortunately, this little limitation limits the number of use cases I have every day in this area greatly. Because at least for me, a lot of the applications that I write are highly configurable. Therefore, I have to read the data from somewhere. I have to reuse a variable. But sometimes you have some natural variables. So in our case, the number of legs, it's really fixed. So we can use it here. So this was also hopefully an interesting one. And last but not least, we only check whether this thing is mutual, the symbiosis, and we use again the discard operator to make it very explicit, to tell the reader of the code that we are not interested into animal 1. And then we have all the different results. Okay, so let's try it out. I've tried it out here. It's a little bit more code here. Put here. Hopefully it will work. So I called it what? Find total revenue. I think this is what I call it. You see, I created some symbiosis. First one is a Fluffosaurus with 8 legs, and then a centipede cuttlebug with 100 legs. So this is our checkbot, and so on and so on. Just believe me, they really work. Let me show you that. Yeah, here it is. And you can check the code afterwards. It calculates everything correctly. The first one is our jackpot. We really got the most out of this first thing. Now, what we used here is we used a class, in this case a record to be more specific. But you can do the same thing with tuples. And then it's also a beautiful syntax. So let me show you a version of find total revenue, but this time we are going to do it with tuples. So let's call this one with tuples. Here it is. And in this case, I'm not saying symbiosis, but I'm using an I animal here, an I animal here, and a Boolean, whether this is mutual or not. And finally, to make things a little bit more easy, because you already saw that we can return tuples from a switch expression, so I think this one should be fine. And now I will copy the entire statement here, and I will walk you through this code. So let me show you what we see here. I think I have to move that one in the next line so you see everything correctly. Yeah, I hope you can read it from back there. Now again, we are using a switch expression. Please note, this is important. For those of you who are not writing C# on a daily basis, this is not a switch statement, it's a switch expression. So you can use it wherever you have an expression. If statement, while loop, for loop, assignment, whatever you want, this switch expression is really powerful. And inside of the switch expression, we can here pattern match on the tuple, you see? So we don't have a type anymore. We don't have the symbiosis type here anymore. What we have is a tuple. And inside of this tuple, we can now apply, let me mark it for you, here and here and here. This time we cannot leave out the discard operator because we have a tuple existing of 3 values, so we have to specify all 3 of them. We can specify patterns for every element inside of the tuple. So again, we say if the number of legs is 8 for the Fluffosaurus and the number of legs for the centipede cuttlebug is pretty high, then we want to do something. I think you get the idea, right? If we take a look at the second one, only type pattern, and discard pattern. The next one, just one type pattern, then the discard pattern, then a constant pattern. And last but not least, here, a recursive pattern with a relational pattern works like a charm, also with tuples. So you see, this pattern matching with switch expressions works awesome with your own types and with tuples. Yeah, but again, I'm very, very sorry. This has to be a constant. This has to be a constant. This has to be a constant. The result can be a variable, don't get me wrong. But these things, they must be constants. You know, besides C#, I'm a big fan of Rust. I do a lot of development with Rust. I love Rust. I think it's an awesome language. And sometimes people tell me that Rust is from a language perspective better than C# or many other languages in all aspects. That's simply not true. I mean, take a look at this pattern matching thing here. It's really powerful. C# can do a lot of things that other programming languages can't. Now let's take a look whether it works. And for that, I have a little bit of a driver here. Here, no, that's the wrong one. Where is the correct one? I got it. Sorry. I forgot how my own sample works. I think I called it find total revenue with tuple, right? So what I essentially do, you can see it here, I'm just using the sample data, which I created up here, and I use a select statement, a link query, to turn my sample data from a symbiosis record into a tuple by extracting the animal 1, the animal 2, and the Boolean flag. And then I'm simply passing that into my find total revenue with tuples. And believe me, I will not run it again. It works. It delivers exactly the same result as before, exactly what we wanted to do. So you see, working with these tuples works really, really well. So, switch expressions with custom types and tuples, check. Now let's get back to the slides. Now, our idol Jim had a really large collection of cameras. He was very proud of them, and he always has chosen the correct camera that was most appropriate for the situation. Now, Jim had all his cameras in a bookshelf like that, and the bookshelf had 3 rows and 6 columns. And he marked every compartment of the bookshelf with some kind of numbering system, like A1 or C4 or something like this. And in his notebook that we got from Jim, he wrote down the location of every camera that he used to take a picture. Now we have to write a method with which we can decode the location of the cameras. So we can pick the correct camera off the bookshelf and use it to make a picture. And we will do that by applying more advanced relational patterns. So let's get back to our code here and create a new region. Here we have the region relational patterns. And this is the function that I would like to write together with you. I called it getCamera, and the getCamera receives a location. And this location could be something like A4 or C3. It must not be something like just A or C9, because we only have 6 elements. By the way, we have to support lowercase letters and uppercase letters. And the first thing that we have to do is we have to verify whether the collection contains a valid location, because maybe Jim had made a mistake and wrote down a wrong location. So obviously many of you will say, okay, regular expressions. No, that's too complicated. For just 2 characters, where the first one is A, B, or C, and the second one is 1, 2, 3, 4, 5, 6. I think regular expressions would be a little bit more too complicated, but maybe that's another story for a different Techorama, a deep dive into regular expressions. I would love to do that. So let's try to do that with pattern matching. And in this case, I have one if statement, which I would like to show you, and I will again analyze it together with you. It contains a bunch of pattern matching. Oh, let's format it a little bit, and now I can zoom in and show it to you on a pretty large screen. First one, let's take a look here. I would like to draw your attention to this line. Here we are using something which is pretty interesting. We are using pattern matching because we have the is operator, but this time we are using a new operator which I didn't tell you about so far, the not operator. Yes, we can write not. Not is now a keyword in C#. It's not the binary not operator which turns true into false or false into true. This is really the keyword not, which can solely be used inside of patterns. So don't try to replace your exclamation mark operator with the word not. It doesn't work. And then we are using here, see that one, a recursive pattern with a constant. So in this case, we are just essentially saying location.length equals 2, but in a little bit different way. What do you think? Will C# compile this one down to meaningful C#? Yes, it does. If you write something like this, at the end of the day, the C# code or the intermediate language code generated will be identical to writing if location.length equals 2. So, two ways of writing it. Use whatever you prefer. Now the next line is a little bit tricky. I would like to draw your attention first on this part here. Oh, again, I love it, right? See, I only need to specify the complicated expression that I have here on the left-hand side only once. I can say is lower than A or greater C. I do not need to repeat the expression here, which I would if I would use the regular ampersand, a logical OR operator. But with the relational pattern, I don't need to repeat that. And it happens in our case that I'm using a binary OR operator, which with a strange bit mask. Anybody knows what this is? This is the technical cool way of saying I know how to turn an uppercase ASCII letter into a lowercase letter, because the difference between an uppercase and a lowercase letter is just a single bit. ASCII was designed like that. So this is just a 2 lower. You do not need to call 2 lower for that. You can simply use an OR operator and then have your colleagues look at you like God. No, I'm just kidding. I'm just kidding. But in this case, I just wanted to have a more complicated expression on the left-hand side to show you the value of these relational patterns and how you can combine them with and or. Well, the second one is pretty clear, I think. It's again the second location, and I'm using another pattern. One thing that I see pretty frequently, people writing something like this, location 0 is greater equal A and lower equal Z, or greater equal A and lower equal Z to check whether something is a letter. Please don't do that. That's very slow. You shouldn't do that. .NET has some better helper methods for that. They can be found in the character class. And here you have things like if is ASCII, digit, letter lower, and so on and so on. And they use all these cool bitmap operators behind the scenes. So don't use a pattern here, a relational pattern, just to check whether something is a digit or a letter or something like this. That's just a mention to the side because maybe, some people will do that. So let's add the rest here. The rest is not very complicated, although it contains a nice little thingy here. In our case, we want to now find out what the cameras are. And you see, Jim had a method. If the A, B, or the A, B, or C, that is now the row, no, the column, the column. If it's the first two, then the manufacturer of the camera is Snappy Snaps. If it's in a compartment 3 or 4, it's Jolly JPEGs, a very interesting camera manufacturer. You should definitely look it up. And everything else is from Pixel Punch. And the important thing here is that we are using the fact, I already told you about it, that the switch expression has a relevant order. I do not need to specify the lower range and the upper range because the order matters. We have the special case lower equal 2 before the more generic case lower equal 4. So the special case is only going to be activated if the value didn't fall into the first category. So the second case only covers values 3 and 4. All other values were covered by the first line in this switch expression. So really nice, again, an application of relational patterns with the switch expression and the fact that the order really matters. And then I apply the same here, but in this case I'm using the switch expression together with different relational patterns. Yes, you can use the constant pattern together with and or. I'm not sure if everybody was aware of that. Many people think that and or can only be used with relations. No, they can be used with constants too. So I can say lowercase a or uppercase a. Then we want to do a wide angle shot with our camera wacky wide angle wonder. If it's B, we want to take the delightful detail camera. And if it's C, we want to take the megapixel mirth machine, whatever that is. Don't complain to me, complain to ChatGPT. These things, I would not be creative enough to come up with names like that. This is what you really use ChatGPT for. Not the useful techie stuff. Coming up with fictitious names, this is what you really use. So, yeah, we have this one, and I think we can try it. So you see it, and then we get into the last chapter of our talk, and you see, it will work perfectly fine. I will not show you the, I will not go through the details. I will just compile it so I see that everything is okay, and you see it looks pretty good. It covers lowercase letters, it covers uppercase letters, so everything is fine. Relational patterns. Relational patterns. And with that, we go into the last 5 minutes of the talk, and we go into the last chapter. Isn't that a cutie? Some of these animals, they move very, very fast. So if you want to have a sharp image of them, you need a camera with a very fast shutter speed. So in this case, we see a Fluffosaurus who is moving very fast through the jungle, but we managed to get a picture of him. Isn't that awesome? But for that, we need to use exactly the right shutter speed. Well, Jim was an expert photographer, and he just knew the shutter speed, but we are not that good, so we have to practice. So what we are going to do is we are going to do some practice photographs with different shutter times, shutter speeds, to see how the shutter speed influences the picture. And hopefully, at some point, we can also take a picture like that. Okay, here we are. So let me copy in the first example. I think I can copy the entire thing here because it's not that complicated. I will walk you through the sample. This is now all about list patterns. You see, here I have a list of shutter speeds. You need a shutter speed is how long the light gets into the camera. If you're not that so much into taking pictures with classical cameras, 1/100th of a second, 1/200th of a second, and so on and so on. And in my case, I now have a collection of photos, and I want to find out whether this was an experiment with structured shutter speeds. So I want to find out if I have a sequence, here you see it, starting with the values 100, 200, 500, 1000, and then additional ones. And this is exactly what I'm talking about. This is a list pattern. A list pattern essentially means that you specify certain values of the list, and then C# will verify that it fits to this pattern. It only works with collections that can be indexed. So you can use an array, you can use a list, but you can't use IEnumerable. You can use one and exactly one ... operator. That means 0 or many other photos, 0 or many. And that's the important one. You could also use an underscore to say exactly one, but I don't care which. Okay, underscore or ... But you can use only one ... operator. You cannot say something, then ... then something, then ... then something. That doesn't work. You can only use one dot dot operator inside of a list pattern. And lastly, what you can do is you can assign certain parts of the list to variables. So here we use the var pattern to assign the rest of the shutter speeds to this variable. Nice, right? Well, I will walk through this sample rather quickly, because when I first saw this feature of C#, I thought, wow, this will make my life so much easier. But it didn't. And you know why? Because these things have to be, can you guess it? Constants. And unfortunately, in many of my applications, I simply don't have constants that I could put here. These values are typically read from a database or something like this. And then I can't use list patterns. So list patterns are great. They are interesting to talk about. They can do a lot of things. I will show you one last sample before we close. But this is no longer everyday C#. What I showed you before, this is really everyday C#. This is something that is cool, but I don't use it every day, unfortunately. Yeah, and here you can see that the dot dot operator can also work at the beginning. But in my very last example that I'm going to show you here, I will show you at least some cool stuff. For that, I need to copy in some final enumeration. Maybe you can already guess what we are going to do, because I'm copying in some shoe types, and I'm going to use a using static shoe type. Did you know that you can use using static with enums? Many people think that you can use using static only with classes to just write down the methods here. With classes, with static classes. No, you can use it with enums too. So I can just write tennis, and it will automatically know that this is a shoe type. I think this is pretty awesome. And let me show you what we are doing here. Our last example, we have our centipede cuddlebug, and this guy has a lot of legs, like I told you, and now this guy, we found one in the jungle wearing a lot of shoes. And now we have to find out what he is about to do based on the shoes. And let me show you how we can do that. Here you have a switch expression, and that's the interesting one, combined with a list pattern. So we can say if the cuddlebug has 3 tennis shoes in the first 3 legs, and then the other shoes don't matter, he's probably going for a tennis match, right? The next one here, he has some tennis shoes mixed with other shoes. Well, maybe tennis, maybe not. Here we see that the cuddlebug has flip-flops at the end of his body, so he's probably spent the rest of the day on the beach. He's going to dance ballet, so you see the cuddlebug has ballet flats on the first pair of legs and belay flats on the last pair of legs. So you can use patterns on the left and on the right. But we can do even more things. We can combine relational patterns. Here you see it together with list patterns. Because all the shoes which are lower than or equal hiking shoes are somewhat related to sports. So if the cuddlebug has shoes lower than or equal hiking, he's probably doing something with sports. And last but not least, we can also extract single elements, not just a lot of elements, out of the list and combine this with the when clause. Again, something which I found that many people don't know, that you can combine the when clause with the switch expression. And that's pretty neat. So you see, with that, we can really find out what our friend, the cuddlebug, the centipede cuddlebug, is going to do. That is what I wanted to show you. So, again, here we have to specify constants. I'm very sorry about that, but still, this is something that I must say that I have used in the past. Maybe only 10 or 20 times, and I do a lot of coding, but still, sometimes it really comes in handy. Time flies. Time really flies. I hope you enjoyed our expedition into the jungle. Maybe you can remember the Fluffosaurus and the centipede cuddlebug. I want to say thank you for joining me on this journey through pattern matching in C#. I hope you enjoyed the last 60 minutes, and I hope you learned 1 or 2 things which are new for you. Please check my Twitter account. I will tweet the link to the slides, and the slides also contain the notes and the link to the GitHub repository where you can take a closer look at all the lines of code that I wrote here. For me, I want to say thank you to you all for joining me. Thank you very much for coming, and have a great Techorama and enjoy using pattern matching in C#. Thank you very much.